Excellent. This is the Analyzing Baseball Data with R book club, and we're into chapter 6 now. Balls and strikes effect, I want to say is what it's called. I don't have it in front of me at the moment. I assume everybody was able to read the chapter. Yes, no, maybe so. And Trevor says he rewatched Moneyball. I'm probably due for a rewatch on that. I read the book 2 years ago. I've seen the movie a couple times, but my memory is, I fortunately I'm blessed with a poor memory, so I can rewatch all these things and enjoy them again. There's a bright side to everything, right? So yeah, this is chapter 5. I'll just bring it up on my screen here. I'll share the chapter that guide the discussion. It's in one of these things. Did I close it by mistake? There's my RStudio 11. There it is. Try that again. All right. Chapter 6, as the book is online, talks about this balls and strikes effect. So let's see. The first thing he does, there's kind of three sections. One is the hitter's effect on the hitter and pitcher counts, right? And so for a single pitcher, and then I guess there's a single batter too. I forget now. Then there's the what he calls behaviors by counts. That's where he actually looks at the actual ball trajectory data, which is kind of cool. And also umpires the same way, behaviors by count, which is kind of interesting too. I think analyzing what umpires are doing is always interesting. While we still have them, I guess they're working toward replacing the plate umpire with a. Well, I don't know if he'll still be there, but he won't be calling balls and strikes. It'll be the computer doing it. It's kind of if that's what they decide to do. I hope they don't, but kind of part of baseball, right? To have the umpire behind the plate. So he starts out with this example for a single pitcher, and this is using the what's it called? The roto wire data. And so we'll skip through some of this. And so let's see if I remember what he was doing here. So this is a figure of the OPS plus, which is a adjusted OPS for each ball and strike account. So this is supposed to tell us something about like how conditional on the balls and strikes, what is the player's OPS plus, right? And I mean, it shouldn't be anything surprising here though, because if the player was already ahead, 3 balls, 0 strikes, I mean, from that point of view, from that point on, he's got a much better chance of having a successful outcome than if he had 2 strikes already down, it's already behind the game. So this shouldn't be surprising, but this is kind of just a warm-up exercise to try to understand the. I wouldn't say this is an effect of the balls and strikes. It's just conditional on balls and strikes. What else do you expect? Is that what you guys' impression was? It's not like this is the balls and strikes is actually having another impact other than the fact you're already behind. It's like, hey, if you're already behind in the game, you're also more likely to lose. It's not because you're. It's not because the score is making you play worse. It's you're already behind. So I don't think the this doesn't tell you that there being 2 strikes behind makes you make bad decisions or anything. It's just you're already behind, right? Does everybody agree with that? Feel free to speak up. I mean, it's the active form. Jump in when you want to. So that's what my interpretation of that part. But I think it was just a warm up of conditioning the data on the balls and strikes that he has. Did anyone have any trouble with any of all this? How he did this in R? You guys are all experienced with R, so you probably know all about the expand grid and all that kind of stuff. So if not, it's here in the chapter. Again, this is going to be a real loose discussion of the chapter, as I said. So that's my interpretation of that. That's what I thought. I was like, well, that doesn't seem to tell me much. I would be surprised if it was different. So then we get to the retro sheet data, not retro sheet data. And inside that data, there's a whole bunch of codes for what the what that pitch was. Like, was it I mean, clearly it's balls and strikes, but there's a lot of other things that can happen. It wasn't even a pitch. The player, tried to do a pickoff on second base, or it was a foul, but there's different kinds of fouls. There's different kinds of strikes too. Strikeout looking, strikeout swinging, strikeout, the guy forgot to write it down during scorekeeping, whatever it was. Um, so all these coded up uh, pitch codes have to be converted into what we really care about, which is just the balls and how many balls and how many strikes at that point in the at bat. And so he goes through a little thing about using string which, string detect to do this. And then the code, I think, is this one of the ones that was like, he's like, well, I only did one example, the rest are in the appendix or something. I think that's the case. So he removes the ones that are not pitches. Um, One thing I want to mention here too, if you have trouble, so I don't know if you saw my Slack post, but I did manage to get in Appendix A is where it tells you how to do this retro sheet, uh, to get this retro, I guess I should back up here. Sorry, you're gonna get seasick watching my mouse. I apologize. Where was it at? I guess we haven't got there yet. So he's still talking about just manipulating the string sequences. So we'll skip through all this. Here it is. So this, right? This won't work on your computer unless you have this file, retro 2016.rds, which is not in the not on there, not on the not directly available on the. Somehow it's in the GitHub repo though, because if you just type data uh, to after you install, install packages. Here, I don't want to share the other screen, but if you just do, library ABDW, what is it? ABDWR3 data, and then you type data retro 216, you'll have that data frame. You'll have the promise for it, then you can just use it. So you don't have to worry about, for this chapter anyway, and maybe for other chapters, when he does this kind of thing, maybe just try the data command or type in that uh, the thing I put in Slack about how to find all the data that's available in this package. And you'll see there's a lot of data available in this package, including this one, and also including the part for the later part with the PX and PY data from StatCast for the particular things he looks at, not for all of it, but for things like umpires in 2016, and what are the other two? I forget. We'll get there. So that's just a little thing I found out. There's not as far as I know, does anyone else find that documented in this book at all, in this chapter, or any chapter in this book that was in there? I think that's a no. Okay. So let's see, we can skip over this if somebody has some questions. So here's just removing the non-pitches, like we said, using this regular expression. And now he's looking for, I'm going to put a couple indicator variables, one for that when it goes to, anytime it goes through a 1-0 count, he'll indicate that. And every time it goes to a 0-1 count, he'll indicate that, for example. And then this is just showing that it's working, that these are given the right values you expect what these codes mean. And the whole point of this was to go back to what we did last chapter with the expected runs matrix. So if you remember in last chapter, we had figured out for each situation what the expected runs were, each count, and how many outs there were, and was there some other part of the state? I forget. It was just who's on bases, right? So which bases, what the count was, and how many outs there were, right? Those are the state situations. So you don't have to worry too much about doing all this C01 stuff, though he just did, because he has in the library this function called retro sheet add counts, which will take care of adding the counts for you without having to worry about parsing it. And that's what he does here to the 216 data. And then this was mysterious. Like, what is this? I don't have this file. That's also, I don't think that's in the, I should check. I don't think it's in the data thing. No. So that's something you had to have made in the previous chapter. So in the previous chapter, he makes this data frame ERM2016. He never says, hey, you should probably save this in your file. I wish you would have. But you can go back, rerun it, grab that, find that, get that data frame. So this is the expected run matrix that you need to be able to figure out what the expected runs were. And all this is just joining that by that thing twice uh, to get the expected runs for each situation. Okay. So yeah, adding the counts.
Ron, that
But
could be a note for the next edition.
yeah, exactly, right? Like
Yeah.
this, I hunted around for that thing. Like, what is this? I had to search the entire book. I'm like, oh, there it is. It's a data frame. I guess if I would have read the previous chapter like right before this, I would have been, on top of it, but that's not how it worked. Or even if I would have read the previous chapter carefully, which I also didn't do. So all this is just to be able to get the expected runs in these different situations and to figure out like in for a particular, so I can say this story because I found this a little bit tricky to wrap my brain around when I was reading this. So correct me if I'm wrong, but I think what he's trying to do here is to figure out if for a certain count, what is the expected runs at that count? And the idea being that now we can disentangle the confuser there because if the player is behind a count, the expected runs will be lower, of course. But if he does better than that, then that's saying something, right? I think is the idea. So, for example, he calculates for just the case of a first pitch strike and a first pitch ball, getting a first pitch strike is better by 0.07 expected runs. So it's some advantage for sure. I don't know whether I should consider that big or not, but but of course that's an expected run. So we know that should be the case because again, better to be ahead than behind, right? In the have more chances to win. Let's see. So then he calculates these run values for all the possible balls and strikes. And I'll just skim through all this and get to this chart right here. So um, this chart is now the average change in expected runs for plate appearances passing through each ball strike count. And again, this makes sense to me because you would expect that if you have this is nothing again, this is not a behavior thing. This is just I keep trying to keep that straight. This is not to say, I mean, he says earlier in the chapter this idea, correct me if I'm wrong, he says this idea that hey, if a player is ahead on the count, he might be a little bit more aggressive. Um, or if he's behind on the count, he might, you know, swing at things to avoid getting struck out, that kind of thing, right? And that's not what this is about, though. This doesn't tell you anything about that, as far as I'm concerned. Am I right about that? Did you guys get the idea? And again, this is just the idea that hey, you're ahead, so of course you're gonna, or you're behind, so of course it's gonna be. I mean, nobody wants to start out with clearly sitting at the on the home plate with two strikes down, you have a much less probability of getting runs, right? Because what do you watch a game? It's like one strike to go, the game's over. Right? It's a bad situation to be in. So I don't think there's anything mysterious about that. What is interesting, you can kind of see, hey, what I think this may was the point. I just kind of missed it. Which counts are the ones that favor the batter versus the pitcher, and that's what you can get out of this. He talks about that. Oh, here it is. Yeah, this little table he makes, right? So these are neutral counts. The haters counts are 3-0, 3-1, 2-0. And I think that makes sense. That's what I would think of as haters counts. And 3-2 is modest haters counts, sure, 2-1. Yeah. I don't think you can argue with that, but you could probably just say this, but now you can put some numbers behind it, right? Say, this is why these are these ways. That's kind of cool. I guess when I was reading this, now that I'm talking it through, I'm realizing when I was reading this, I kept expecting him to come back to this earlier to come back to this point of the batters and behaviors, which we're going to get to in a minute, but about whether the batter is a little more aggressive or not. But you can't tell that from this kind of data. Okay. Let's see. What was the point of this section? The previous count. Thought we were done with this section. Oh yeah, that's a minor little digression. I'll skip that because I don't remember it that well anyway. So this right here is now we're talking about, so he says he provides this R data file. I don't know where this is. Couldn't find it, but you don't need to worry about it because it's the same kind of thing. You can just type data Cabrera, data umpires, data Berlanda, and all these things will be delivered to you in your as a promise in your environment. So it's kind of nice. So you don't need to, I think this is something I wish I would have known about 4 chapters ago. Hey, there we go. I just tried it for the heck of it. And so these things have the pitch. Now this is now pitch by pitch data. I mean, the other day is kind of pitch by pitch data, but this is pitch by pitch data, which has the locations of where the pitches cross the plate, which is kind of cool. That's the StatCast thing, right? So for example, he uses that data to make this plot. Just shows where the balls and strikes went for this entire, like this is a sample of 500. This Cabrera data, what is it? It's 2000, 4 years, I think, yeah, 4 years of batting data for Michael Cabrera. And this is those pitch locations, but it's a sample, a random sample of 500 of them. And also whether he swung at it or not. So you kind of get the idea where he's comfortable swinging or not from this. Somebody just posted a textbook. I thought I couldn't find those things in there. We just poked that up here. Oh, yeah, here you go. So they are separately in here as RDAs. Oh, here it is. So this is where they come from. This is when you do the data thing. It's just they're coming from here. So if you have the lab package installed, they're in there, or you could download them this way. But did not check. I don't know why I didn't take a look in there. Or maybe I did. And I was looking for an RDA file. So that's where the data comes from. Very good. Very good. Anyway, the this kind of gives you an idea of his where he feels comfortable swinging at the ball, as it were, right? What's the name for that? Swinging tendency. Okay, swinging tendency. But it's kind of hard to get anything out of this much because there's just a scatter plot. You can kind of see by eye, but he then instead proposes to draw contour plots, and to do that, he fits this data to a LOES, a two-dimensional local linear fit, right? And that's what this is, right? So it develops a LOES plot for this, and then makes a little grid to calculate the fit from that on, right? And then, which is what he does here, calculate what the predictions are for that fit, and then he uses that finally. I'll skip through this and to make these contour plots using geom contour from ggplot. So if that is not crystal clear to you, which is not to me because I actually kind of went through this pretty quickly, I should probably go back and do it, but you should join me going back later and looking through all this, make sure we understand how these plots are made because I don't make these kind of plots very often. But it allows us to, now this is the same data, but now shown as a probability of throwing your pitch there, as it were, fraction of pitch is shown, thrown, and that gray box is supposed to be the strike zone. The view is from the catcher's perspective, it says. I didn't realize that. Okay, interesting. I would have not thought that. Just happened to notice that. So the whole point of that was not just to look at his strikes, his swinging tendency for all cases, but rather to see if this changes when he's behind or ahead of the count. And so he restricts his attention here to like even, behind by 2, or ahead by 2. No, behind by 2 and ahead by 2. And to look, so he just goes through the same thing, just filtering by those counts, doing those fits, and we get this answer here. So it looks like when he's neutral, he's got pretty much the same swinging tendency as his average swinging tendency, maybe a little bit looser. When he is ahead, no, behind, I don't know, I can't get that straight. 2 strikes. So he's behind. Now he's like swinging at practically anything to try to avoid um, getting struck out again. And then this, he said, in the notes, he says you can't really get much out of that, just not enough data. So low sample size, it doesn't tell you much what happens when he's, so that's disappointing. But I guess we can imagine that he's not swinging it very much at all in that situation. That's why there's so much low data. Is that's would be my interpretation of that. Again, feel free to jump in if you had some other observations about any of these things, but that's what I got out of that.
He broke the model on that
Yeah,
too.
yeah, I did. Yeah,
Yeah, I think this would be like a good, I know this is for the last chapter, but I feel like, building a Shiny app around this would be a cool
yeah,
application.
yeah, it would be. Yeah, because I think there's clearly a lot more to explore just in this piece of the data. So the next side, now we switch to the other side of the plate, other side of the plate to the pitcher side of the at bats. So he picks a pitcher, Verlander. Again, this is 3 years, I think, or 4 years of data from this guy. 2009 to 2012. Okay, and this is 15,000 um, observations. And so one thing, this is why I asked the question on Slack about what these different pitches were, because he talks about, well, like the data also has like what the pitch types were, four seamer, uh, curveball, I guess, and change ups and sliders and whatever else is two seamer. I did read that. It's not quite, I haven't, internalized that. I already forgot kind of what I know a fastball and curveball, and I know a change up, but the rest of them were kind of like, what does that mean exactly? So I'll have to internalize that at some point. So the first thing he does is, well, how does I think his first thing he talks about is pitch selection, like I say before, but first, oh, so by batter handedness. So this kind of makes sense, I guess. So it turns out that for left-handed batters, he tends to throw more changeups than he does for right hand. I think that's because it's hard to keep the changeup from hitting the the batter sometimes, but or maybe I got the wrong pitch for that. But I know some of these pitches tend to go pretty crazy. Look at the slider too. Maybe the slider's the other way around. So that might have something to do with the way the ball moves, right? Does that make sense, Trevor? Am I getting that close to being correct?
Yeah, for sure.
Although I know they sometimes like to like dust the batters right off if they can for fun to throw them off. So what we really wanted to look at here was their pitch selection by count. So that's what all this manipulation is for. I'm not going to go through it in any detail again. And this says, okay, here you go. There's a result. So and this is uh, given the ball strike situation, what are the proportions of different of his different pitches that he threw? So then there's some text describing what you're supposed to get from this, but let's see. For example, when he's behind, he tends to use his four seamer 7 times out of 10. That goes up to 78% when he's trailing 3-1 and 81% on 3-0 counts. So
Statcast has a really cool visual, basically showing this. And since Verlander is still pitching,
oh,
I put that in the chat.
this thing. Oh, oh wow, that's kind of cool.
Yeah, so nice visual. And it shows it by the pitch breakdown too.
So the little circles here are the pitch breakdown. Okay, I see. Ah, cool.
Yeah.
That's pretty interesting.
And then a sweeper is a new pitch, so that's I think that's in the MLB pitch definition I put in the
Okay.
Slack channel.
Yeah. Huh. Interesting. Okay, then the last section, I think that's the end of that part. The last section is about, which I thought for me was the most interesting section, was this umpire behavior thing. This idea of the compassionate umpire. I had to go look that up. It's pretty cool. Um, the idea that the umpire might narrow or widen the strike zone. I mean, narrow the strike zone a bit when the batter's behind, where the pitcher's ahead, whatever you want to say. But so this is just going to see how valid that is. So the data. Here's the umpire's data frame. Again, either you can download the RDA file directly or just use the data command. Since it's in, if you install the package, it pulls it up, and you can sample the 20 umpires just to see what's sample at 20 umpires just to see what the data frame looks like. So this is again reduced data from the StatCast. You don't have all the other columns. He's reduced it down for you. So here's the umpire. Here's the handedness of the batter at that time, the situation, the actual pitch location, and whether or not it was a called strike or not. So this kind of data is pretty cool. I'd like to know how you can get that real time. People do because I see on Twitter there's a guy that posts the umpire scorecards. I don't know if you guys have seen that, or an X, sorry, umpire scorecards after the game. It's kind of fun to see how they're doing. So he does the same thing using Loas. Loas, how do you pronounce that? I was Lois, Loas. Anyway, I mostly just type it and read it. So the same kind of thing, focusing on just I think the three situations again, even, both far behind and far ahead. The most, I guess, the extremes in one middle case. So using the same type of math he did before to generate contour plots, this is what we find out, and it does seem to hold up. That I think, right, that, well, at the very least, so when the pitcher is well ahead, right, the strike zone is about what the strike zone should be. Maybe not exactly. This is not perfect contour, I'm sure. Yeah, umpire scorecards. That's right. He just posted that in chat. Trevor did. Whereas when it's two strikes, the umpire is compassionate, and the strike zone suddenly becomes much smaller, and you'll get some called balls that should have been strikes, right? So it does seem to hold up. Although now I wonder, after you publish that article, whether umpires read that and say, "Wait a minute," and now they are trying to counteract that effect actively or not. I have no idea. But it's pretty interesting, I thought. I think it's interesting because of things like that umpire scorecard. It looks like you could do some analysis like that, do some like additional analysis on the umpires. But that's basically it. I did look at one of the exercises. Did anyone do any of the exercises and wants to share anything with that? I mean, at the end of the day, at any of these things, if you guys do an exercise, you want to share it, no matter who's presenting, feel free to let the presenter know. I'm sure they'd love to have you take over at the end and share your exercises. So if you do them, you can come prepared to do that. It's always fun. I did look at the umpire strike zone one for left-handed versus right-handed batters, but I'm not going to really bother sharing that because I didn't find it. I didn't get any. Maybe I did it wrong. I didn't really get any interesting. If anyone else did, I was going to say, hey, let's compare, but I didn't find any real difference from a left-handed to right-handed batters when I did it. So I don't know. I don't know if anyone has an analysis of that. Also, somewhere on the internet, whether or not umpire strike zones change a lot for left-handed or right-handed. There might have been a little bit of a shift in the contours, but it could also have been noise. So that was my result for that exercise. I didn't look at any of the other ones. Well, this would have been interesting. I've had more time. I would love to look at this by pitch type, because that's actually more interesting, because you might think, oh, sometimes the pitchers seem to try to get away with something with some of these sinkers, right? It's like the catcher tries to make it seem like it was not crossing the plate at the right angle. So be interesting if they ever do get away with that. When the strike zone dips down, you see what I'm saying? But anyway, that's basically, unless somebody has anything else to share about this chapter, which I'm surely welcome. I don't have anything else to share, but I thought it was an interesting chapter. A lot of interesting data. I don't think you would really learn R from this book, because he does just jump right into some rather advanced things with tidyverse and things. So, but if you already a good book, if you like baseball and you just finished like R for Data Science, it'd be a perfect book, because you can really exercise a lot of those things and apply it to baseball. So with that, I'll stop sharing. Does anyone have any thoughts they would like to share at this time?
I feel like this would be a good chapter to like jump off into the new StatCast data that they have with the
Yeah.
swinging angle and squaring up and everything.
Yeah, the what's his name? There's a guy that does a YouTube channel that works for one of the baseball teams. Not YouTube, Twitch. That was
Yeah,
just streaming about this the other day. I didn't get a chance to really watch it, but I saw he was talking about it. Oh, you know what I'm talking about because you're on that. I know you're on that channel.
I can put it in the chat too.
Yeah, yeah,
Uh, but yeah, I think he streamed about the new baseball data last night, and I think will tonight as well.
oh, okay,
But if you can't make it, the videos are posted on his
yeah,
channel afterwards. Yeah, there's the link to the channel.
yeah. Dick Juan. He's using Python. Just so you're aware, but nothing wrong with that. He mostly talks and doesn't do that much if I watch him. He seems to be a lot of time talking, but once in a while he gets in there and does some data analysis, I assume. Don't tell him I said that. He'll get mad at me again. He's already mad at me for accusing him not to use Bayesian methods. What are you talking about? I do. So, okay. Very good. So next time, I guess we'll hit the stop button here.